Hey everyone, and welcome to this explainer. Today, we're doing something a little bit different. We are taking a journey that moves way beyond the surface-level glitz and gossip of the world's most extreme private residence. We're going to peel back the incredibly opulent layers of this towering structure to uncover the hardcore structural secrets hidden inside. We're looking at a building that literally pushes the very boundaries of modern physics, and we're going to break down exactly how they pulled it off.
All right, let's just dive right in by starting with the number $2 billion. Now, just to put that into perspective, homes are typically built to, comfortably house a family. But when you start attaching a $2 billion price tag to a single family residence, you aren't just building a home anymore. You are projecting power, permanence, and absolute prestige.
To really wrap our heads around Antilia's place in the world, comparing it to other ultra-exclusive properties shows you just how rare this tier of real estate actually is. At the very top, you've got Buckingham Palace, a literal royal residence with 775 rooms valued at $4.9 billion. Sitting right below it, firmly in second place globally, is Mukesh Ambani's Antilia at $2 billion. Notice how it completely dwarfs other legendary properties? I mean, it makes the historic Villa Leopolda on the French Riviera at $750 million, or that infamous mega mansion The One in Bel Air at $500 million look relatively cheap. Antilia is second only to the British Crown.
So what exactly do you get for that kind of money? Let's do a rapid-fire run-through of these extravagant, frankly mind-boggling amenities. We are talking about a 6-floor garage with enough parking space for 168 cars, a 50-seat private movie theater, a dedicated snow room that literally pumps out artificial snowflakes to beat the Mumbai heat, 3 rooftop helipads, and to keep this entire massive vertical city running smoothly, they have accommodation for a 600-person live-in staff. It's just an unparalleled level of customized luxury.
And then there's the sheer vertical scale of the thing, which is absolutely staggering. Rising 160 meters high above Altamont Road, this is a 27-story property stacked vertically in space-starved Mumbai. It completely overwhelms the skyline. And because of its incredibly high ceilings, this 27-story structure is actually as tall as a standard 60-story building. It is a massive, incredibly heavy tower just looming over the city. Which brings us to a crucial question, and really the whole point of our deep dive today. We're pivoting from luxury real estate gossip into the fascinating, hardcore engineering required to keep this titan standing. You've got hanging gardens, swimming pools, heavy marble, and cantilevered floors all suspended hundreds of feet in the air. How on earth do you ensure a building with this unusual shape and immense weight doesn't simply tip over or collapse?
Part 1. The Blueprint of Extreme Wealth. Engineering an Earthquake-Proof Palace.
Okay, so to build an earthquake-proof palace, the secret lies entirely in the sheer depth of the foundation. To support a 60-meter-high, irregularly shaped tower like this, the building relies on a massive 3-meter-thick reinforced concrete raft foundation. This gigantic slab is embedded deep below the 2 lower basement levels, resting directly on a very hard rock stratum. This is the ultimate anchor. Without this incredibly dense base, all that luxury suspended above just simply could not exist.
But actually getting that structure off the ground was a huge headache. Originally, the UK-based designers conceived Antilia as a structural steel-framed building. But there was a massive logistical problem. The structural steel members required were incredibly heavy. It was seen as almost impossible to fabricate them, drag them through the congested streets of Mumbai, and erect them on site. Plus, butt welding those giant pieces on site, that was considered way too unreliable. So, the engineers had to completely rewrite the playbook. They switched the entire core design to a reinforced concrete framed structure, all while miraculously keeping the architect's original vision intact.
And that new concrete skeleton wasn't just built to hold up cars and swimming pools. Despite the delicate interior motifs of suns and lotuses you see inside, the brutalist concrete core had to be engineered to withstand a magnitude 8 earthquake. Even though Mumbai is traditionally in seismic zone 3, the owners decided to adopt the much stricter parameters of zone 4 as an abundant precaution. The engineers opted to rely on sheer brute strength rather than ductility, pouring massive amounts of high-grade concrete to guarantee total stability.
Now here's where it gets really tricky. Notice how the service core, which houses all 9 elevators, 2 stairs, and the service shafts, isn't in the middle of the building. It's eccentrically placed right on the eastern face. While this was great because it opened up the floor plans for the living spaces, this unusual irregularity created a massive engineering headache. It completely threw the balance of the building out of whack. Because that massive service core was all shoved to one side, computer analysis showed that the non-uniform dead load, meaning the sheer static weight of the building materials themselves, would cause the 27-story structure to naturally tilt westward. So how did they fix it? This is pure genius, honestly. The engineers purposely constructed the service core with a calculated, deliberate eastward tilt. They basically built it crooked on purpose, so that once the building was fully loaded with its own weight, it would settle back into a perfectly vertical position.
All right, so earthquakes and dead loads are one thing. But what about the wind? At 160 meters high, wind forces are absolutely intense. They actually had to conduct wind tunnel tests in London to assess exactly how much the building would sway. Now, international standards usually allow a slight acceleration of about 15 millig's, a tiny fraction of gravitational force at the top of tall buildings. But the clients? They didn't want to feel a thing. So engineers massively increased the stiffness of the structure, reducing the acceleration to a barely perceptible 8 to 10 millig's. Basically, when you're watching a movie in that 50-seat theater during a severe storm, your popcorn won't even rattle.
Part 2. Cantilevers and hanging gardens. Shifting our focus to the mid-levels of the structure, take a look at those massive blocks protruding outward. Those are 9-meter cantilevered floors, hovering high above the city skyline, located at the 101-meter and 108-meter levels. Just imagine standing in a living room that literally hangs 9 meters out over thin air, supported entirely by the internal spine of the building. But here's the catch. Concrete doesn't magically float in the air while it dries, right? To pour those cantilevered floors, they face an absolute logistical nightmare. They had to erect a specially braced 56-meter-high temporary staging platform all the way from the ground up just to support the formwork for these specific overhangs. This towering temporary support had to be held perfectly in position for over 2 months while the massive superstructure above it was cast, cured, and fully secured.
And what about those incredible V-shaped columns holding up the gardens? Well, they're actually inverted pyramids. Here is how they built them, step by step. First, they took a main load-bearing megacolumn and split it into 4 separate, tapering circular columns. Second, because these were a massive 1,600 millimeters in diameter and uniquely shaped, they had to fabricate highly customized semicircular steel forms for each and every one. Finally, they had to erect these massive tilted columns and hold them completely freestanding for 22 meters in the air until the upper floor was finally cast to tie them all together. It was literally a high-wire balancing act with thousands of tons of concrete.
So what you have here is what I like to call the iceberg concept. What the public sees, the mother-of-pearl interiors, the crystal chandeliers, the multi-story hanging gardens, that is just the tip of the iceberg. None of that floating luxury is possible without the hidden depths of uncompromising physics sitting right beneath it. We're talking high-grade M60 concrete, custom wind tunnel stiffness, and a solid foundation 3 meters thick locked right into the bedrock.
And this brings us to a fantastic summary from the engineers themselves. Sterling Engineering stated, "The challenging design of Residence Antilia stretches the boundaries of architecture and engineering. It is a prime example of how extreme wealth doesn't just buy square footage, it literally buys the ability to push the actual limits of what modern engineering and construction can accomplish on planet Earth."
Which leaves us with a pretty wild bot to chew on. When a private residence requires wind tunnel testing in London, magnitude 8 earthquake bracing, and a $2 billion budget, what are we really looking at? Are these towering structures simply homes where a family eats and sleeps? Or are they something else entirely? Permanent, vertical monuments to legacy, influence, and unparalleled power. Think about that next time you look at a city skyline. Thank you so much for joining me on this explainer, and keep questioning the world around you.